Yeah, hello everyone. Finally, I found some time to record another tutorial. Today we are building a point grower effect, as you see here. It's not too complicated, but first we start with some explanation how the effect actually works, and then we dive into building our node setup, and at the end I will show you an advanced setup with some more parameters to do some different effects. Okay, I think we can dive into the explanations. So what we need first is an initial point for this setup. This could actually be more than just one point, but we build it with one point first. From this point, we are building a random direction. And if we add this random direction to the position of the point, we are building a new point here. Then from those 2 points, we are doing the same step, building again random directions from each point. And then we are building the first condition. So we check if the new created point is close to the other points. If there are too close to other points, we don't create this point. So that's the first condition. Then if we go further, if we would do this just with this one condition, we would just build a big blob of points. That's not what we want. So we have to build a second condition, and this condition we build with a noise. So we add a noise to the setup, and then we build a threshold. So we check if the new point is inside the noise threshold, you see here with the blue points, or outside of the threshold here, the red points. And with this condition, we say if the point will be created or not. And then at the end, we collect all those points and we feed them into a volume builder, and then we have here our point growing solver finished. Okay, here in Cinema, what we need first, we need a capsule, because we like to build this inside of a capsule. We do this with an object group capsule. So search for group, and then here we have the object group capsule. Then we double click it and maybe arrange it to here. So now here we can start with our setup. So what we need first is an initial point, and also what we like is give this point an age attribute, because we build this inside of a memory, so inside of a solver. So with this age, we can at the end build a vertex map to build kind of a gradient over the surface. You will see this at the end, but okay. We can build our initial point by building an array. So type in build an array. Then the element type here is vector. So we just want one initial point at this here at the center here of our scene. So x, y, and z is 0. And then we duplicate this, and we want our age, and the age will be integers. So maybe call them age and positions. Because we want to grow our points over time, we have to build our setup inside of a memory node, so inside of a solver. So type in memory, and this here is our memory solver. Here we have initial types. So our first initial type is the position array, and the second one is the age array. So let's switch the first add a second input. So, and the first, both of them are arrays. So switch the type to array. Then open them, and inside the first array we have vectors. So replace the float value with a vector. So this is our position array. And then the second one we replace with integers. So now we can name them here. Oh, positions and maybe h. Then plug them in here. So let's jump into our solver. So the first thing we like to do here, as in our explanation here, let's go up here. We need a random direction. So we can do this with an hash node. And here inside of the hash, we have here the vector 3. So this is our random direction. We want them from -1 to 1. So we have a direction like 360 degrees. And this direction we like to normalize. Normalize means the random vector is always the length of 1. So then we like to add this vector to our position. So we iterate here over position. At the moment it's just one point position, but this will increase over time. So we have to iterate over our points. We do this with an iterate collection here. So, and now it goes inside of the array and iterate over all our positions here. They will come out here from the element port. And because here when we go back here, the length, we want to decide how long is this length. So we can multiply this normalized vector, use a multiply. Sorry, we can do this with it's better to do this with a scale. There's a scale node that's perfect for this. So switch to vector. And now we like to scale the vector. Maybe we start with 2. So our point separation will be 2 centimeters. And then we like to add this vector here to our position. So this we can do with an add. Type is vector. So we add here our random direction to our position. And then this new position we like to add to our new array. So we can do this with an append node. So the data type here is also the same here as our position. It is an array with vectors inside. So, and the array we want to put in is here our incoming array here. And then we add here our new point, and this will go out here to the next output. So now in this array here we have 2 points now. So we like to organize it a bit. So if you hold Control and Shift and click on the here on the wire, then it generates here a knot. So we can organize it and maybe take this free, and we say Control G, and then it builds a scaffold. And here we say random direction. So, and because here our random direction should be different for every point and for every frame, we have here a seed and salt. So you see here 2 seeds. We can use them. First we feed in here our index to the salt. It doesn't matter. Could also go to the seed. And then we build a time node. Here the time node. And then here our frame time we put in here into the seed. So that means for every point we have a random direction on every frame. Oh, that's perfect. So now we want to visualize them. So let's jump outside of the memory solver. And here we have our positions. And let's iterate over the positions. And just to see if it worked, use a matrix operator. Oops, that's the wrong one. Matrix operator. Feed in the positions here to the matrix, and then let's maybe use a sphere. Sphere. And now the sphere is just a geometry object. We like to have it as an operator. You can right click and then toggle the node, and now the sphere is a whole operator object. So feed this into the matrix, then to the output, and now they are way too big. Because we said in here, our scale here is 2 centimeter. Let's say the sphere is also 2 centimeter, then go close, whoops. Ah yeah, and because we took the first here, the previous output, we actually need the next output. Now we see here the second point with the radius of 1, of course, because here the scale is the width of the point, and now we can see those 2 points are lining up here. So if we play it now, you would see we get a lot of points. Let's play, and you see we get pretty fast this point cloud, and what we see, we have intersecting points. That's not what we want. That's why we are building now our first condition to check every point if they are too close to another point, and if this is true, we don't add the point here to our append element. So we can check if they're intersecting with, let me first make some space here, with our good old friend, the closest point. That's a super handy node. So here when we go close, we see we need the geometry and the query position. So the query position is actually a position that checks every point of the geometry here with this value. So we can check here the distance. So we say like this is 2 centimeter, the same that we use here. So it checks just 2 centimeters, and if it finds a point that means okay, there is 1 point too close, so that's good. So we can use this. So our geometry is actually all our points. So here we can also feed in just a point array. It don't need to be a geometry object. And then our query position is here, our newly created position. This goes in here. And then the distance is our scale. So let's make a parameter for this. Just drag it here outside and then say add a new input, and then maybe say here point separation, or maybe point scale, scale. And then let's go back here to the closest point, and you have here this little circle. When you click Control and click on the circle, it shows the input port. So let's put this in here, and you can drag here the input here to the node area. So it generates here an input node. Let's call this point scale, so you can organize it better here with those, so you don't have all the wires going here to the inputs here. here on the closest points, we just need to check one neighbor. That's okay. So now let's check the length of the indice array. So you can use a get count. So if the closest point finds a closest point, there is one here inside. So that means if the get count is bigger than 0, or it is not 0, that means there is a point to close. So we can use this information to decide if we, here for the append element, to decide if we like to add the new point or not. So we can here show the count, and then we use a condition. We can do this with a compare node here. So we like to compare the integer, so an integer, so here the count of our get count node, and then we like to check is it equals to 0. This if there is nothing inside, so there is not another point to close, so that's fine. So now we can use this compare here for the count. Okay, let's check. Let's press play. Okay, and we see generates here our blob, but there are no intersecting points now. So next we don't want actually like those clones of spheres. We want just points, just geometry points to use them inside of a volume builder. So we have to replace this part here. So an easy way to add those points into a geometry is an set point node. You can use a set point, or you can use also an it's called geometry property set here, and switch this to here unchecked array mode. So you can use those both, that they do the same. So but we use the point set, and now we have here an empty geometry, and we add our positions here. So in our empty geometry, it adds points. So delete this here, and then here our geometry to the output, and now we can see nothing. So because we just have points, maybe when we here make the current state to object, you have here our geometry, and when we go to point, we see here we have points. So but this we can now use inside of a volume builder. So put this inside a volume builder. Now it's way too big. Our point separation is 2 centimeters, so we go here also to 2 centimeters, and then here to our use the mesh points, and we say the mesh points are a slight bit bigger, and voila, we have here our volume builder, and of course then the volume builder inside of a volume mesher. So now, because we don't want just a big blob of points, we want we now build the second condition here with our noise. So let's jump back into the memory node, and let's build the second condition. So first we need a noise node. So it's called sample noise. Here the sample noise, and we like to sample here our new position. And then the noise value we also like to compare here. So we use a compare. So float, that's fine here. The noise value is a float value. So this into the compare, and now we want to check if it is greater than our threshold here, as here our threshold that we define here. So maybe start with 0.5, and this we also like to have as a parameter. And now we like to check if both of these conditions are true, and if they are true, then we add the point. So we use a Boolean operator for this, and here the operation is AND. So if this is true and this is true, then this will also be true, and this is here our new count here. So you already see something changed. So let's go back and let's press play. See, something's going on. Maybe some more frames. Yeah, it looks already nice. So now we'll also like to change the parameters here of our noise that gives our final effect. So let's make maybe the noise type, maybe the seed and the scale here. Name them noise type and the seed. Then let's jump outside, and then here the same. We want those parameters on our capsule here. So scale, threshold, noise scale, noise type, and the seed. So now we have here our parameters we can play with. So maybe let's make the scale of the noise much smaller, something like this. Then maybe stopple. Let's check. Zoom out. I think the noise is still too big. And if we go lower with the threshold, I think it grows faster. Yeah, you see that makes a huge difference. So I think you have to find here the sweet spot, or maybe leave it at 0.5, and let's play. And then you start to see the noise. And now it's just playing around with the settings. We want not as dense structure as we have here, then maybe just up this here to 6, and now start to find because our start point is now outside of the threshold, we have to find a seed that the start point is inside of the threshold. This looks good. Let's play. Yeah, nice. Yeah, that looks okay. And now we like to have the age of our points as a vertex map, as you saw in the videos that I showed you at the start of the tutorial. So we have this gradient. So let's prepare our age value. So that's pretty simple. Dive into the memory, and then we have to get all our ages. So for every position we need an age value. So first use an get element to get the age, so get our corresponding age value to the position. So we use here the same index as our positions. So now we have the corresponding age value. So at this we like to raise by 1. So we use an add. Oops. The type is integer, and we add 1. And then we like to set the new age value for each point. And we can use a set element. So also the age array. So we can maybe make here also a knot here to clean this a bit up. So, and then the index is also this one here, like this, and then our new value is like the age raised by 1. And then we also have to append this to our age array, so it is the same procedure as here. So we use also an append element, but the type is now integers. So maybe call this here append positions, and here append age. Then add the age value here, also clean it up here, maybe like this. And oops, sorry, this one has to go here because the set element gives us a new array. So like this. And then also the same condition. And then the age here to the output. And now because we are, oops, delete this. We are iterating here with the iterate collection. So we are inside here, inside an iteration, we iterating over all positions. And now we are kind of closing those iterations. We could close here with the curly brackets our iteration. So put them in here. So we know, okay, here the iteration ends here. Then let's go back. And now here the age, we like to map our age to a vertex map. So first we need a, it's called geometry property set. Where is it? Oops, typed in get set. So, and here we like to set a new vertex map, maybe call this H. Then here our geometry. And then we like to, because we have here already an iteration, we like to get this corresponding age of the point. So also same procedure as inside of the memory node. Let's get the age and the index in here. So now we have here the corresponding age. And then here in the geometry property set, we uncheck the array mode. Here also this to the geometry output. And then because our weight map is from 0 to 1 and our age goes to how far our time line is, so we have to map those values. You can use a range mapper for this. Range mapper, so the input into here, and we say the output will be 0 and 1, that's fine, and maybe say, okay, from age from 0 to 100 will be 0 to 1. So in a vertex map, it is like from white, black to white. And then this into the iteration. And now we see there is no vertex map generated. That's because we have no initial point for the moment. So I can add some additional points here to build now. Because we have here additional points. It already has a start point here. So now it creates here our vertex map called H. And maybe this value here we want to also control via a parameter. So add this as a parameter. And maybe call this H max. And then let's play it a bit. Oh, I think, yeah, let's go. And now maybe switch the layout. And now we like to map here our edge to the volume builder. So let's build here a vertex map for our volume builder. And then add our edge, and you already see here, okay. It's mapped to the vertex map of the volume measure. And now let's build a material. Add this to the volume measure, open the material, then type in vertex, and then add here our vertex map to the attribute name, add this to the color. You already see, okay, there is our color. And then maybe ramp it with a gradient. Let's use here a preset, maybe something like this. Switch it, invert the gradient. And now let's play. And you can see and then, of course, the rest is like typical cinema stuff. You can go to the volume builder and smooth it. It's way too much. Maybe just like the mean value, something like this. Oops. So, and also the same with the vertex map. You can smooth this one also. Can go here to max and then decide here, yeah, how much you like to smooth it. So yeah, and then of course, as you saw in my example at the start, the rest is just simple texturing and stuff. So yeah, now it's up to you what you like to do with it. So yeah, that's the whole thing. How to build this kind of point growth solver. So now here inside the advanced capsule here, you see that a lot of the same settings, but additional setting is kind of an influential direction. So it adds to the random direction, you can influence it. So maybe when you type in here in the Y direction 1, so the point grow will go into the Y direction. You see it goes up. So you can also animate this to make kind of a circle growing. And then there is also a collision setting. So it collides here with, for example, this head. So it stops growing outside of the head. So, and if you like to have more than just one start point, of course, you can always go inside of the capsule and replace here the build array, add more points, or replace it with a geometry object. So the position of geometry object, and then your growing simulation will start where the geometry is. So yeah, that's it for this tutorial. I hope you liked it. As always, if you have questions, write it to the comments. And in the description, you find the link to Gumroad, where you can find the tutorial file and the advanced setup. Bye bye.